This is going to be Chapter 9, Trigonometric Identities and Equations. So Chapter 9 is going to be a very important chapter. If there's something that you really need to understand about this entire class, it's probably Chapter 9. So Chapter 9 you will be using, especially the solving equations, a lot in calculus, and you'll probably see a lot of it again in pre-calc as well. So the first thing that we'll talk about is verifying trig identities. So when you think about an equation, you kind of can say that this equation is just going to be basically a mathematical statement that may either have three different choices. So you can always be true, it can always be false, or it can be true for some values. Okay, so the ones that we're really going to be able to look at in this particular section are equations that are always going to be true. Okay, so sometimes we have found equations where they're always false. Okay, so for example, if you were to have this equation 2x minus 1 is equal to 2x plus 3, you can see that this is always going to be false, because if you subtract the 2x over, kind of like this, what you end up getting is negative 1 is equal to 3, which we know that's never going to be true. Okay, so you have equations that look like that where it's always false, it's a contradiction. You have some equations that are going to be true for some values. So if you were trying to solve the equation 2x minus 1 equals 4, then the answer here, x in this case, will be 5/2. And you know that that's going to be the only one that works for that. If you plug in another x value that's not that, then it's going to be not true. So we're only going to look at equations that are going to be always true. Okay, so no matter what x value you plug in, these guys are always going to be true. So let's here I give a kind of like an algebraic example. If you look at this equation, you can kind of see that this kind of doesn't look like it's an identity, but it really is. So really what we're going to be doing here is we want to show that the left-hand side, so this is the left-hand side, I'm going to call it LHS, is equal to the right-hand side, which is going to be RHS. Okay, so I kind of wrote it here also. Whenever I say left-hand side, I'm going to say LHS. Whenever I said right-hand side, I'm going to say RHS. Okay, so the way that you kind of want to verify whether something is correct or not is proving that one side is equal to the other. Okay, and basically you just want to work with one particular side until you can find until it becomes the other side. So it doesn't matter which one. So here I kind of give you an example of what I did. So I'm choosing the right hand side. So the right hand side is basically this guy right here. So I wrote it down. What we can do here is that we want to make sure that this guy looks a lot like the left hand side. So one of the things that we can do is we can FOIL this guy out. Notice that on the top you're going to have x squared minus x plus x minus 1 divided by x. You can see that the middle terms are going to go away. So then in that case, that's how you get this guy, this x squared minus 1 over x. Now what you can do is you can divide this x into both of these guys. So see how this x is being divided, right? X squared over x minus 1 over x. And then you can see that one of the x, for this guy, one of the x's is going to go away. So you're going to have, okay, so there's a mistake here. This guy right here should be x minus 1 over x. Because if you see over here, let me erase this guy. I accidentally forgot the x. I put a 1. Because this guy should be over here. So this guy, I'm going to go ahead and get rid of it and write an x. Okay, so let me just go ahead and do it over here. Let me just show you that this is actually true. Okay, because, yeah, okay, so there's a mistake there. Okay, so basically you want to prove this guy is equal to this guy. Okay, so you're going to say x plus 1, x minus 1 divided by x. FOIL the top part, and we know that we get x squared minus 1 over x. And then I'm going to divide both sides. I'm going to get x squared over x minus 1 over x. And then I have two x's on top, one x on the bottom. That's just going to give me 1x by itself minus 1 over x. Okay, and you can see that this guy is equal to this guy. Okay, so yeah, just make this little note. This shouldn't be a 1, it should actually be an x. Okay, now something else that I could have done is I could have easily also started with this x minus 1 over x, which is basically the left-hand side, and did a little bit of algebra to prove that it equals the right-hand side. But you can see that doing so is going to be a little hard, to kind of do that. But we can still do it. So let me show you how we can do that. So another way is that you can start with this guy and show that it equals the left-hand side, the right-hand side. So a way that you can do is that you can find the least common denominator here. So notice that this guy has an x, so this guy has to have another x. I'm going to put an x on the bottom, okay? And then I'm going to multiply the top one by an x, so that's going to give me x squared. So just finding the least common denominator. So then I can subtract this guy, x squared minus 1 divided by x. And then notice that on the top part I can factor this, x minus 1, or x plus 1, x minus 1 over x. And notice that this guy is now equal to the right-hand side. Okay, so you kind of show that that this is an identity, that they're both equal to each other. Okay, so it doesn't matter which one you start off with. You can start with the right hand side or the left hand side. It should give you the same exact thing if it really is an identity. So this whole process is what we call verifying identities. So whenever I say verify the identity, this is basically what you're doing. Okay, so you could have started with the left hand side first or the right hand side. Okay. So, what we're going to be doing is that this is kind of like this process that we're going to be doing with these problems, but instead of just regular x's, you're going to have sine, cosine, cotangent, all this other stuff. So, one of the things that you have to be able to know is that you have to tap into your algebra skills, so such as factoring, conjugates, a lot of these little divisions of polynomials. You have to be able to be very comfortable with those. So here what I did is that these are not steps. These are more like tips or ideas or ways that you can try. It doesn't mean that you have to go 1 through 6. It's just some things that you can do. So one of the things that I would just suggest, the first thing that you should kind of just consider is that you should probably simplify the most complicated side of the equation. So whatever is the most complicated side, that's the one that you want to kind of start off with. Try to use the basic trig identities to substitute things into the equation, okay? Factor and multiply whenever you have a chance, okay, to simplify a couple of expressions. If you basically did these 3 things and nothing really seems to be happening, try to convert everything into sine and cosine. Usually converting them into the sine and cosine is usually really nice, okay? Things hopefully will cancel out. Try multiplying it by the conjugate. So if you forgot what conjugates are, basically what it is that if you have 1 plus sine of x, something like this, the conjugate of 1 plus sine of x is going to be 1 minus sine of x. So basically what a conjugate does is that you have the same, this is basically the same thing. The only thing that's different is that the sign is in the inside, like the positive and the negative are going to be opposites. That's what a conjugate means. All right. And then the last thing is just try something. Okay, you really just have to try something using whatever you think you can do. I mean, usually sometimes it's really hard to start the problem, but you just got to start it. Really there's really nothing else that you can do. Just start it, or else you're just going to be there drawing a blank. Okay, so here on what I did is I wrote down some of the identities that we have kind of known. So these are the reciprocal identities, which you already are very used to. So you know that cotangent of theta is equal to 1 over tangent of theta. Cosecant of theta equals 1 over sine theta. Secant of theta equals 1 over cosine. And then you also have these quotient identities, which is basically tangent is equal to sine over cosine. Cotangent equals cosine over sine. And then you have our Pythagorean identities. Sine squared theta plus cosine squared theta equals 1. Tangent squared theta plus 1 equals secant squared theta. And 1 plus cotangent squared theta equals cosecant squared theta. One thing that I will also emphasize is that sometimes you're going to have problems where this identity will not be used, but kind of like a redoing it a little bit, like rewriting it. So I can subtract sine squared theta to the other side. And notice that you're going to get that cosine squared theta is going to be equal to 1 minus sine squared theta. Okay, so sometimes you might have to do a rewritten form of the original equation. And similarly, sine squared theta is equal to 1 minus cosine squared theta. So sometimes you're going to have to maybe do something like this. Okay, so, and most frequently, for the majority of the time, you sometimes have to use these identities very, very often. So do keep them in mind that you can rewrite the first one and even the other ones, but usually it's the first one that rewritten. You can rewrite it and to find what the cosine squared theta is or the sine squared theta is. Okay, so this is kind of like a little preview of what we're going to be doing in this in this section. In the next video, I'm gonna do a couple of problems so that you guys can kind of just see how we kind of verify these guys.